Hi, I'm Andy and this is question 6 on the AQA Decision 1 paper from June 2006. For more questions on this paper, click the eye in the top right corner. In question 6, we have a garden with two types of trees, palms and conifers. We've got various constraints, we've got something to help us form an objective function, and it says that x represents the number of palm trees and y represents the number of conifers. And in part A, we need to form a linear programming problem. So first of all, we're going to look at the constraints one by one and write them down. So it says he is to plant at least 10, but not more than 80 palms. And so if x represents the number of palms, we can write down that x must be greater than 10, but less than or equal to 80. The second condition says he is to plant at least 5, but not more than 40 conifers. Well, the number of conifers is represented by y. So that means that y must be in between 5 and 40. We're also told that we cannot plant more than 100 trees in total. Well, to work out the total number of trees, I'd add the number of palms and the number of conifers. So that tells us that x plus y must be less than or equal to 100. The next one is a little bit more challenging. So we're told that each palm needs 20 litres of water each day and each conifer needs 60 litres of water each day, and there are a total of 3,000 litres of water available. Well, if it's 20 litres for one palm and we have x palms, the total number of litres for the palms will be 20 multiplied by x. And the total number of water required for the conifers, if it's 60 for 1, will be 60y. So we get 20x plus 60y. And if the total amount that we've got available is 3,000 litres, then this must be less than or equal to 3,000. As 20 goes into all three of these numbers, we can divide through and simplify this inequality. So we would get x plus 3y is less than or equal to 150. So we now have four inequalities, 1, 2, 3 and 4, and we also have an objective function to write down. We have a profit of £2 on each palm and £1 on each conifer. So we'll call our objective function P, and we're going to make £2 on each palm, so that's 2 lots of x, and £1 on each conifer, which is 1y or just y. So my objective function is P equals 2x plus y. Okay, next up we need to draw a suitable diagram to enable the problem to be solved graphically, indicating the feasible region and the direction of the objective line. So this graph is figure 3, and our first constraint we need to draw is that x is between 10 and 80. So we need to draw the lines x equals 10 and x equals 80. They are going to be vertical lines through 10 and 80. Okay, I'll draw them in red so they show up a bit better. Vertical line through 10 and a vertical line through 80. And because x has to be greater than 10, we'll shade out the left hand side of this. Remember, we're shading the region that we don't want. So we can have anything to the right of this line so far. And x must be less than 80, so anything to the left of this line. Okay, our next constraints are y is between 5 and 40. They will be horizontal lines, one across from 5 and one across from 40. And we want the region below the 40, so we'll shade out above the line. And we want above the y equals 5 line. Next, we've got the line x plus y equals 100. Now, normally to draw a line like this, I would use something called the cover-up method. I would say when x is 0, cover that bit up, then y would have to be 100, and y is 0, then x would have to be 100. Well, in our case, the 100 is okay over here, so we can plot the point 100, 0, but we can't plot the point 0, 100, so we need another point on the line. So what you might do is choose a point for y and figure out what the x number would have to be. That way you know the y point will be on the graph. So if we, for example, say, well, what happens when y is 50? Well, that would give x plus 50 is 100. That would mean x has to be 50 as well. So we've got 50, 50. And as long as we've got 2 points, that's enough information to draw the line. So 50-50 is this point here. And we can draw a line from 100, 0 up through 50, 50. And it says x plus y must be less than this. So we want to shade out the region above the line. Lastly, we've got x plus 3y equals 150. Again, we'll use the cover-up method. So if we said that x was 0, 3y would equal 150, y would equal 50. So we need to draw the point 0, 50. Again, this won't work if we were to set y equal to 0 because we get x equals 150. So we need to choose a point on the line. Well, remember we need to choose a value of y that is on our graph. So let's say, for example, we chose y to be 30. Then 3y would be 90, and if we subtract that from 150, we would get x has to be 60. So we can plot the point 60, 30. And as x plus 3y has got to be less than 150, again, we're going to shade above the line. So this region here is our feasible region. We'll label it in a minute once we've drawn our objective function. So to draw the objective function, we've got p equals 2x plus y. All we need to do is pick a number for p and then draw that straight line. So there are any number of objective lines you could draw to get the marks, but it makes sense to choose one that's not really small in the corner and not really big so that it goes off the graph. So for example here, I know my largest y value is 50. All I need to make sure I do is choose a number that 2 and 1 go into. So for example, I might choose 30 equals 2x plus y. And then if we were to let x equal 0 here, that would mean y would have to be 30. And if I was to let y equal 0, x would be 15. So I would get an objective line that goes through 30 on the y-axis and 15 on the x-axis. So I'm going to label this region FR for the feasible region and label this line OL because that's the objective line. And that is part 2 finished. In part 3, I need to find the maximum profit. So what I'm going to do is use this objective line to find the point within this region which gives me the maximum profit for x and y. So in order to do that, I'm going to take my ruler, rotate it round and then put it on top of my objective line. From here, I will move my objective line up the page until I find the last point where it leaves the region. So it's already left up here and here. And if I keep going on, it's now left this one, and the last place that it leaves is this point here. Now, you can't as easily as me keep your ruler parallel to the page here, so what you may want to do is put your ruler on the line and draw some very, very faint markings along the ruler, and then keep moving it until you get close enough to the region that you can actually tell what's going on. So all of these lines are parallel to my original line, which means they're technically objective lines. And once I got to about here, I could fairly easily by eye see that it's going to be this point here. So this point is my max value. So for part 3, my max profit is at this coordinate here, which is 80 on the x-axis and 20 on the y-axis. Therefore P equals 2 lots of 80 plus 20, which is £180. In part D, we've got a new pricing structure with £1 of profit on each palm and £4 on each conifer, and we need to find the new maximum profit, and also this time, different to part C, we also need to write down the number of each type of tree in order to obtain this maximum profit. So we need to draw a new objective line with this £1 profit for palms and 4 for conifers. So we'll call this P2, and that's going to equal £1 for the palms, which is just x, and £4 for each conifer, so plus 4y. So we've got to draw a new objective line here for x plus 4y. For this one, remember the max value on my graph is 50 for y on the axis, so I need a number that when I divide it by 4, it's going to be less than 50. So I'm going to choose my value of p to be 80. So 80 equals x plus 4y. So when x equals 0, 4y is 80. That's going to give me y equals 20. So 0, 20. and when y equals 0, that means x will be 80. So I need to draw a line that goes through 0, 20 and 80, 0. So we'll label this OL2. And again, we'll put our ruler on this line and move it until we leave the region. Okay, if you wanted to, again, you could draw these dotted lines, but I'm not going to do it for this one. And if we move the ruler up, the last point where we're going to leave the region is right up here. And so it's quite difficult to see on the computer screen, but that is at this value here, which is x equals 30 and y equals 40. So in this case, my profit will be 30 plus 4 lots of 40, which would be £190. But make sure you explicitly answer the question as well. So we would buy 30 palms and 40 conifers.